Right now you're connected to a global web, billions of minds, machines and moments all linked. The internet lets you watch a cat in Tokyo, call a friend across the world, or access all of human knowledge instantly. It's so natural now it's hard to imagine life without it. But just decades ago, this universe didn't exist. Back then, knowledge meant libraries, and connection meant letters or static-filled phone calls. The journey from that world to ours is a story of visionaries, Cold War fears, and unexpected breakthroughs. It's not just about technology, it's about our drive to connect and share. And it all began with a bold question. What if our machines could talk to each other, even in a disaster? Imagine the mid-20th century information moved at the speed of paper and postage. Computers were massive, isolated machines reserved for governments and universities. They couldn't share data, each was an island. But visionaries like J.C.R. Licklider at ARPA dreamed of a network of digital commons for sharing knowledge instantly. The Cold War made this dream urgent. The military needed a resilient, decentralized communication system, a web with no single point of failure. The solution? A network that could reroute information around any damage. This blend of scientific vision and military necessity set the stage for ARPANET. The ancestor of the modern internet was about to be born. The internet's roots lie in the 1960s when thinkers asked, could computers be more than isolated calculators? J.C.R. Licklider envisioned man-computer symbiosis, humans and machines collaborating, sharing resources from anywhere. His intergalactic computer network shifted focus from computation to communication. This vision inspired researchers like Leonard Kleinrock, who explored how such a network might work. The Cold War's urgency and ARPA's funding turned Licklider's dream into a real engineering project. The idea to connect computers as nodes in a vast, resilient web. The groundwork for the internet was set. The next challenge: how to send data efficiently between computers. The old telephone model, circuit switching, was too rigid for digital data. Enter packet switching. Break data into small packets, each with its own address and sequence. Like mailing book pages separately, packets could travel different routes and be reassembled at the end. This method, developed by Kleinrock, Davies, and Baran, made networks efficient and robust. Multiple users could share lines, and if one route failed, packets found another way. No single point of failure. Perfect for military needs. Packet switching became the backbone of ARPANET. With packet switching solved, ARPA launched ARPANET, connecting 4 supercomputers across the US. Each site had its own hardware and culture, making communication a challenge. The Solution Interface Message Processors, or IMPs, early routers that handled packet switching. In September 1969, the first IMP arrived at UCLA. After intense setup, the first node went online. Soon, SRI joined, linked by a high-speed line. The network grew node by node. The stage was set for the first computer-to-computer message. History was about to be made. October 29, 1969. UCLA's lab buzzed with anticipation. Charlie Klein sat at a teletype terminal, ready to log in remotely to SRI's computer. Each letter of the word login would be sent and echoed back, testing the new network. Klein typed L. It arrived. Then O, success again. But as he typed G, the system crashed. The first message ever sent over the ARPANET was simply LO. A humble, accidental beginning, poetic in its simplicity. After fixing the bug, they completed the login. But LO became the symbol of a new era. The world's first digital handshake had happened, and nothing would ever be the same. In the 1980s, the digital landscape was a patchwork of isolated networks like ARPANET. Universities and corporations were developing their own networks, creating digital islands that couldn't communicate. The challenge was connecting these networks, leading Vint Cerf and Bob Kahn to envision a network of networks. Their work laid the groundwork for the internet, shifting to a decentralized architecture that enabled explosive growth through universal protocols. The universal language that would unite these disparate networks was a suite of protocols known as TCP/IP, which stands for Transmission Control Protocol/Internet Protocol. Developed by Vint Cerf and Bob Kahn throughout the mid-1970s, this two-part system was a masterpiece of engineering. The Internet Protocol, or IP, acts like the global postal service. Its job is to handle the addressing and routing of the data packets, figuring out the best path for them to travel across the vast network of networks. Each packet is given an IP address, a unique identifier that tells the routers exactly where it needs to go, much like a street address on an envelope. The second part, the Transmission Control Protocol, or TCP, acts as the meticulous and reliable shipping manager. While IP handles the delivery, TCP ensures that the message arrives intact and in the correct order. It takes a large file, breaks it down into those numbered packets before sending them, and then, at the destination, it carefully reassembles them. If any packets are lost or corrupted along the treacherous journey across the internet, TCP detects the error and requests that the missing packet be sent again. This combination provided the perfect balance, a fast, flexible delivery system paired with a robust and reliable verification process. For years, TCP/IP was just one of several competing networking protocols. Persuading everyone to abandon their own systems and adopt this new standard was a monumental task. The turning point came on January 1, 1983, a day now known as Flag Day. On this date, the United States Department of Defense, the primary funder of ARPANET, mandated that all computers connected to their network must switch over to using TCP/IP. This was a high-stakes, all-at-once transition. Engineers worked tirelessly to ensure a smooth switch, and when the deadline arrived, the old protocol was switched off and the new one was turned on. The transition was a stunning success. This event was the Internet's equivalent of the Big Bang. With TCP/IP established as the mandatory standard for ARPANET, it quickly became the default choice for other networks that wanted to connect to this growing backbone. It created a powerful network effect. The more networks that adopted TCP/IP, the more valuable it became to join the club. This single unified protocol broke down the walls between the digital islands. For the first time, a true, sprawling, interconnected network of networks was born. The technical foundation for the modern internet was now firmly in place, ready for the world to build upon it. In the early 1980s, a problem emerged. Computers used numerical IP addresses like 192.0.2.1, which were hard to remember. Paul Macapetris and John Postel created the Domain Name System, or DNS, in 1983. DNS acts as the Internet's phone book. When you type google.com, your computer queries a DNS server to find the corresponding numerical IP address. The genius of DNS was its hierarchical and distributed nature, creating a scalable, resilient system. DNS transformed the internet into a realm of memorable names. While ARPANET had successfully proven the concept of a wide-area packet-switched network, its use was strictly limited to military and government-funded research projects. Commercial traffic was explicitly forbidden. This created a bottleneck for the broader academic and scientific community. Universities across the country had burgeoning computer science departments and researchers who were desperate to connect to the internet but they couldn't get access to the ARPANET. A new solution was needed to open up the floodgates of connectivity and serve the needs of civilian science and education, which were exploding with new ideas and data. The answer came from the National Science Foundation, or NSF, an independent United States government agency dedicated to promoting science and engineering. In 1985, the NSF initiated a program to connect its 6 supercomputing centers with a new, high-speed network. This network was called NSFNet. Initially, it was just meant to give researchers access to these incredibly powerful and expensive supercomputers. However, the NSF soon realized they had a much bigger opportunity on their hands to build a new internet backbone for the entire academic and research community, a successor to the aging ARPANET. The NSF took a brilliant 3-tiered approach. They built the main NSFNet backbone, a high-speed highway connecting the supercomputing centers. Then, they funded the creation of regional networks that would connect to this main backbone. Finally, they provided seed funding to individual universities and research institutions to help them connect to their regional network. This strategy created a powerful cascade of connectivity. It was like building a national highway system, and then providing funding for states to build on-ramps, and for cities to build local roads leading to those on-ramps. It was an incredibly effective way to rapidly expand the reach of the internet. By 1988, the NSFNet backbone was upgraded to run at 1.5 megabits per second, a speed known as T1, which was astonishingly fast for the era. This new, faster network quickly became the dominant internet backbone in the United States, carrying the vast majority of the traffic. As more and more universities and institutions connected, the old ARPANET became increasingly redundant. It had served its purpose as the pioneering testbed. In 1990, having passed the torch to the more robust and expansive NSFNet, the ARPANET was officially decommissioned. The internet had moved out of its military-funded infancy and into its new life as a global infrastructure for science and education. The story of the internet in the 1980s isn't just about protocols and infrastructure, it's also about the people who used it and the communities they built. Long before Facebook and Twitter, there was Usenet. Created in 1980 by graduate students at Duke University and the University of North Carolina, Usenet was a worldwide distributed discussion system. It was a place where people could post messages, called articles or posts, to public forums called newsgroups. It functioned like a massive, decentralized bulletin board, with topics ranging from highly technical computer science discussions to debates about science fiction, politics, and hobbies. Unlike ARPANET, Usenet was designed to work over standard telephone lines using modems, which made it accessible to a much wider range of universities and even some dedicated hobbyists. It wasn't a single network, but a set of cooperating servers that exchanged articles with one another. A message posted in one location would slowly propagate across the network, passed from server to server until it was available to readers around the world. This created a vibrant, if sometimes chaotic, space for conversation. It was the internet's first great experiment in large-scale social networking, a digital town square where anyone with access could have their voice heard. Within Usenet, a unique online culture began to form. This is where many of the conventions of online communication were born. Users developed acronyms like LOL for laughing out loud and BTW for by the way to add nuance to the text-only medium. They created emoticons using keyboard characters to form smiley faces like to convey tone and prevent misunderstandings. They also encountered new social problems like flame wars, those heated, angry arguments that could derail a discussion, and the need for netiquette, an informal code of conduct for polite online behavior. These early pioneers were mapping the social terrain of cyberspace for the very first time. These early communities, including Usenet and various mailing lists like the one for science fiction fans called SF Lovers, proved that the internet was more than just a tool for accessing remote computers or transferring data files. It was a powerful new medium for human connection and community building. It allowed people with shared interests to find each other, regardless of their geographic location, and to form strong social bonds. This deeply human aspect of the network was a powerful driver of its growth. It showed that the ultimate killer app for the internet wasn't file sharing or remote login, it was connecting people to other people. By the 1990s, the internet was a powerful but chaotic universe of information. Data was locked away in separate, incompatible systems. It was a fragmented and frustrating experience. There was no single, unified way to access the vast sea of knowledge. For the internet to reach its true potential, someone had to weave all these disparate threads of information into a single, cohesive fabric. The internet needed a system that was simple, open, and universal. This problem was felt most acutely at places like CERN. A British computer scientist would have an idea that would transform the internet. Tim Berners-Lee, a software consultant at CERN, saw his colleagues' frustrations with accessing information across different computers. In March 1989, he proposed a decentralized hypertext system. His boss called it vague, but exciting, and gave him the go-ahead. This side project became the World Wide Web. He created the first web browser, also called World Wide Web, and the first web server, launching the first website by Christmas, 1990. It was the first node in a web that would soon span the entire globe. Tim Berners-Lee invented three technologies that work together: HTML, URL, and HTTP. HTML is the language used to write web pages with tags like headings, paragraphs, and hyperlinks. URLs are the universal addresses for content on the web. HTTP is the protocol that allows web browsers and servers to communicate. Together, these innovations formed a simple system. CERN released these technologies for free, ensuring the web would grow as a public good. Tim Berners-Lee's browser ran on a specialized computer few owned. In 1993, a team led by Mark Andreessen created Mosaic at the University of Illinois. Mosaic displayed images in line with text, a game changer. It transformed the web into a rich multimedia experience. Mosaic was user-friendly, easy to install, and free. It unlocked the internet, use skyrocketed. Mosaic turned the web into a global phenomenon. With user-friendly browsers, the web was no longer just for academics. It was a wide-open frontier, and a massive land rush was about to begin as entrepreneurs realized its potential for commerce and communication. The internet was fully privatized, opening the floodgates for business and the dot-com era. Companies like Amazon, eBay, and Yahoo sprang up, promising to revolutionize everything. The stock market soared, fueled by a speculative frenzy. The dot-com bubble would eventually burst, but its impact was profound, laying the foundation for the modern internet. The new millennium began in the wreckage of the dot-com bubble. The party was over. But beneath the ashes, the internet itself was stronger than ever. Out of this landscape emerged Google, started by two Stanford PhD students. Google's algorithm ranked a page's importance based on how many other pages linked to it. Google provided a clean, simple, and accurate way to find exactly what you were looking for. Google thrived, becoming the undisputed gateway to the internet. As the 2000s progressed, a new philosophy for the web began to take hold. The first wave of websites, the so-called Web 1.0, had largely been a one-way street. Companies and institutions created static web pages, and users consumed the content. It was like a digital library or a broadcast medium. But a new generation of services began to view the web not as a collection of pages, but as a platform for participation. This new era was dubbed Web 2.0. The core idea was simple but profound. The users themselves would create the content and the value. The web was evolving from a read-only medium to a read-write medium. This shift was enabled by new technologies and a new mindset. Services like Blogger and WordPress made it incredibly easy for anyone to start their own weblog or blog, publishing their thoughts and ideas to a global audience without needing to know any code. Wikipedia, launched in 2001, took this idea to an even more radical extreme, creating a massive, collaborative encyclopedia written and edited entirely by its users. These platforms weren't about a central authority pushing information out. They were about harnessing the wisdom of the crowd. The internet was becoming a conversation, a dynamic space where content was constantly being created, remixed, and shared by the community. This participatory culture was the fertile ground from which the next giants would grow. In 2005, a new video-sharing website called YouTube appeared. Its premise was revolutionary in its simplicity: broadcast yourself. For the first time, anyone with a cheap digital camera and an internet connection could upload a video and share it with the world. It bypassed the traditional gatekeepers of media, the television networks and movie studios. It unleashed a torrent of creativity, from funny home videos of cats and kids to citizen journalism and educational tutorials. YouTube demonstrated the immense power of user-generated content on a massive scale. This transformation fundamentally changed our relationship with information and media. We were no longer just passive consumers, we were active creators and participants. The line between audience and author began to blur. This new participatory web was more dynamic, more democratic, and far more chaotic than what had come before. It was a platform where communities could form, voices could be heard, and culture could be created from the bottom up. This collaborative spirit set the perfect stage for the next and perhaps most powerful evolution of the internet: the explosion of social networking. You know, the desire to connect with other people has always been at the heart of the internet's appeal, right from the earliest days of Usenet and mailing lists. But, in the mid-2000s, this impulse was really supercharged by a new breed of website: the social network. Early pioneers like Friendster and MySpace had already shown the potential, letting users create personal profiles and connect with a network of friends. MySpace, in particular, became a cultural phenomenon, a riot of customized pages, music, and self-expression that just captured the imagination of millions of young people. It was kind of like the digital equivalent of a teenager's bedroom wall, a place to define your identity and see and be seen by your peers. Then, in 2004, a new player emerged, initially limited to students at Harvard University. It was called the Facebook. Created by a student named Mark Zuckerberg, it was cleaner, more exclusive, and more focused on real-world identities than the chaotic world of MySpace. Facebook's approach was to map your existing social connections, your friends, your classmates, your family, onto a digital platform. It introduced the news feed, a constantly updating stream of your friends' photos, status updates, and life events. This was honestly a stroke of genius. It turned the social network from a static directory of profiles into a dynamic, addictive window into the lives of the people you cared about. As Facebook opened its doors beyond college campuses and grew at an astonishing rate, it fundamentally changed the nature of online interaction. It became the internet's new town square, its default social layer. It wasn't just a place to connect with old friends. It became the primary way people shared news, organized events, and participated in public discourse. Other platforms followed, each catering to a different mode of communication. Twitter, launched in 2006, introduced the concept of microblogging, forcing users to be concise with its 140-character limit, creating a real-time pulse of global conversation and breaking news. The rise of these massive social platforms represented a new centralization of the once decentralized web. While the internet's technical architecture remained distributed, the user experience was increasingly mediated by a handful of powerful companies. These platforms learned how to capture and hold our attention, using algorithms to personalize the content we see, keeping us engaged, and collecting vast amounts of data about our behavior and preferences. The social web had connected humanity on an unprecedented scale, but it also introduced complex new questions about privacy, influence, and what it means to live our lives so publicly. The internet was once a place you visited via a bulky desktop. Early mobile web access was slow and frustrating, but that was about to change. On January 9, 2007, the iPhone was unveiled. It offered the full internet in a pocket-sized device. The iPhone and subsequent Android phones fused the digital and physical worlds. The App Store created a new software ecosystem. Apps put the internet at our fingertips. The smartphone became a digital Swiss Army knife. Mobile computing made the internet a ubiquitous utility. It changed everything. The internet became a layer on top of reality. From its humble beginnings as a military experiment to its current state as a global nervous system, the internet's journey has been nothing short of miraculous. In just a few decades, it has evolved from a tool for a handful of scientists into an omnipresent force that shapes the daily lives of billions. It has democratized information and connected humanity in ways previously confined to the realm of science fiction. This unprecedented connectivity, however, has come with its own profound challenges. The same platforms that bring us together can also drive us apart, amplifying misinformation. The tools that were built to connect us now also hold the power to monitor and monetize our every click. We are constantly faced with a choice. Do we cede control, or do we fight to preserve the open democratic spirit that made the internet so revolutionary in the first place? The internet of tomorrow will likely look different to us. The rise of artificial intelligence, the metaverse, and decentralized technologies point towards a future where our digital and physical lives intertwine. These technologies present exciting possibilities and daunting questions. The one constant has been the human desire to connect, to share, and to know. The story is far from over. We are all active participants in its writing. The most important chapters are likely the ones that have yet to be written. The future is a blank page, waiting for our input.